Hi, good evening everyone. So myself Mithun. So today I am going to talk about Kubernetes and overall overview. So what is Kubernetes and why we should learn Kubernetes? So basically Kubernetes is a container orchestration tool designed by Google. Okay. And so why we still need to learn Kubernetes, and Kubernetes is there from many years now. Okay, it's like landing on a Pluto when people are still trying to figure out Mars. Okay, in the sense, in this context, if I have to say, it means that people are still learning other tools. Okay, so there are many organizations who still does not use Kubernetes. Okay, so people are still happy with other container orchestration tool like cloud based ECS, right? Or they are happy with Docker Compose and the stuff. But still, there are other, on the other hand, there are many companies who are adapting to Kubernetes and they are already ready for their production grade cluster. Okay, now, Kubernetes is so powerful that it is suitable for a production grade cluster. So first let us understand what is the term Kubernetes. Okay, so Kubernetes is derived from a Greek word which means pilot or a helmsman of a ship. Okay, so as for a big ship, there will be one uh, pilot or one controller who will be controlling a big ship. So in a similar fashion, Kubernetes is derived from that word, and as you can see, its logo also it indicates the wheel. I mean the driving wheel of a ship. So that is about the naming convention on how it got right. Okay. So if I have to talk more about Kubernetes, it is a production grade container orchestration tool or system. Okay, it was developed on Google Ground based on Borg and Omega projects. Okay, and it is more than 10 years old. Okay, so Google, as we all know, they spawn billions of containers per week and they are using Kubernetes. So the version of Kubernetes production grade was one version 1.0.1, and today we have 1.28 some dot x. Today I am talking about today. Okay, isn't it? See, as you can see, lately the latest was in the year 2018 it was 1.13.0, but if you see the current trend in the year 2023, it is already we are in the one version 1.27. Okay, and all the services in the Kubernetes are natively load balanced. Okay, that means it is having the capability of self-healing. That means it can scale up and down dynamically, and which is used for self-healing and rollback. Okay, so Kubernetes will always try to and steer the cluster to its desired state. For example, if I am the administrator or like Kubernetes administrator, and I want to spin up some three healthy instances of Redis cluster. Okay, so Kubernetes will say, okay, I will ensure that there will always be three instances up and running. Okay, and then if some out of the three, if one of the container dies, then it will going to replace by another healthy pod. Okay, now coming to the architecture of Kubernetes. So the basic unit of uh, or smallest unit of work in Kubernetes is known as a pod. Okay, so if you are familiar with Docker, you will understand that. So what you will do first, you will install the Docker daemon, and then you are going to run the containers on top with the help of the Docker daemon. But here the Kubernetes will add one more abstract layer on top of the container. So let me open up a uh, board here and let me explain. Okay, now this is what I have already written, but I want to explain now the concept of pod. Okay, so the basic unit of work in Kubernetes is pod. This is which I am writing right now, and inside the pod there will be multiple containers running. Usually you can have one or more, but we prefer to have only one pod. Sorry, one container inside a one pod. Okay, so which you can see in the diagram. But in this diagram, you can also spin up the one more container inside a pod. But usually now on a production grade cluster, we always prefer to have one container in one pod. Okay, and please remember, as same as in Docker, they are ephemeral. So if you want your data to be persistent, you need to have a external volume. So that is all very complex topics, but today's agenda is we are just focusing on the architecture of the Kubernetes. Okay, so the basic unit of work is pod. So pods are one or more containers that share volumes and namespace. You're getting the concept? Okay, now we are not going further on the services and other things. So today we are going to focus on Kubernetes architecture. So what does Kubernetes architecture consist of? So it consists of, so if you first let me compare with the Docker, okay. So what Docker will have, so you will have a EC2 instance, right? So let me draw here. So you will have a, just a second, to have, okay. So this will be a your server, okay. It can be your EC2 or any VM. So what you will do, you will first install the Docker daemon, and with the help of the Docker daemon, you will run the container. Okay, but what if your application is of 2 container or 3 container, then you would require a Docker compose file, and probably you will write a Docker compose file like this YAML, isn't it? So it's very hectic, and even then after writing this YAML files, so you will notice that self-healing capacity is not there with the Docker. So you need to manually interfere and scale the number of containers. So that is where the Kubernetes will come into the picture. Okay, so this is the high level architecture of the Kubernetes. So let me maximize for you guys. Okay, now the Kubernetes consists of one or many master controller. A minimum one master or control plane should be there, and apart from that, you can have one worker node or two or many worker nodes. Okay, and if you notice here, Kubernetes is also sometimes known as k8s. So why they call it k8s? Because of the fact that between k and s, if you notice, there are 1 2 3 4 5 6 7 8 letters. So that is the reason they also named it as a k8s. Now if you observe the diagram here, the Kubernetes architecture consists of a master or a control plane and the worker nodes. And these worker nodes, what they will do, they will act whenever they received any input from the master. So how they received? So they receive any input through the API server. So this guy here. So API server is the main, he is like a receptionist. If someone asks me what is the API server, he is like a receptionist. So any communication between the cluster is happening through this API server. And this API server communicates with all the other components of master and worker nodes. So this API server receives any API request via kubectl. So kubectl is the CLI interface through which the API server receives the any commands. Okay, so the API receives it and stores in the etcd. So etcd is another component of Kubernetes cluster, where it is a brain of k8s or Kubernetes. So why I am calling it as a brain? Because all the information about the cluster is stored in the key value format in the etcd. Okay, so that is the reason I am calling it as a brain of Kubernetes cluster. And once it is stored, then the request go to the controller. So the controller is the guy, he's like a boss in the master or control plane. So this guy is managing everyone. So this controller will tell the scheduler, hey scheduler, we have received a request from the API and we have stored the required necessary information in the etcd. But now what we have to do, you have to schedule the pods in the worker nodes. And the scheduler will talk to the API and it will talk to the kubelet. So kubelet is that service which is running on the worker nodes, which is responsible for running the pods inside the worker nodes. So this service, so this component will be there in every worker node. Okay, then this, as we have one more component known as kubeproxy. So kubeproxy is guy which is responsible for communication between the pods. If there are two pods inside worker nodes, right, so it will help in communication between the pods. And container runtime, you, I need not tell you. So as we have seen here, so we need a Docker daemon to run container, right? So we need a container runtime like Docker or CRIO. Okay, there are many container runtime. So as per the production or your organization requirement, you will install those things. Okay, so these three components like kubelet, kubeproxy and container runtime will be there in the worker nodes. And these are all the components of master nodes like etcd, API server, scheduler and the controller. So this is the overall flow. So if I had to write a like flow again, so we will give any command via kubectl, and the kubectl will talk to this API server, and this API server, what he will do, he will store that information in the etcd and it will tell the controller, and the controller will tell the scheduler, and this scheduler via API it will talk to the kubelet and it will schedule the pods. So this is the overall how the architecture will behave. So everything is done by the kubectl. Okay. So even if you look at the official documentation, it is exactly the same. If you see here, let me maximize a bit. So it is the API server through which all the communication is happening. So he is the main, you can consider him as a waiter also. Okay, so when you go to the hotel, whatever you want, you will order it to the waiter. So waiter will do the job and he will talk to all the folks and he will get the job done for you. In a similar fashion, the API server is the main guy here who receives all the information from your nodes and from the kubectl. Okay, so these are all the components and this is a high level overview of Kubernetes cluster. Okay, so from this I wind up my session, guys. Thank you. Bye bye, take care.